one video that I saw on the internet in
The Wes Anderson
Wes Anderson video.
Did you like by chance ask anyone who made the Wes Anderson video?
Yeah. The first question that I asked from a colleague and of course Dr. Mombal. Luckily, she was my lab buddy. Question: who made that video? And she said, I made that video.
It is with my great pleasure to be inviting Dr. Qazi Kamran Amin to Behind the Science. Welcome, Kamran.
Thank you. Thank you for having me for this session.
So, Kamran, please introduce yourself.
My name is Qazi Kamran Amin. I'm a clinical research assistant too here in Precision Medicine Lab. A little bit into my background and academic background. I have done my schooling from Loverdir, and I belong to Loverdir, of course. And then I did my FSc from CAD College Swat, and after that I got admission in Rahman Medical College, where I did my MBBS. And after MBBS, I was pretty much inclined to research and science in general. But as I have studied medicine, so it was more related to the medical aspect of research, clinical research mostly. Then after my MBBS, I joined different hospitals where I worked as a medical officer and was also involved in research alongside the job which I was doing there. And then I joined the Precision Medicine Lab, and I'm working here as a research.
So how did you come to know about Precision Medicine Lab?
How I came to know about Precision Medicine Lab? Some time to show like-minded Khattak, they say, then I was following different research scientists and social media. I would say on LinkedIn, where I saw Precision Medicine Lab. The platforms, Instagram, it is a research lab, right? It is so cool. The environment, the culture, is so creative. For example, my favorite, one of my favorite directors is Wes Anderson. Wes Anderson, meme did I'm sure the film style still shots they shot a video in his style. That was the case for me. Oh, they know Wes Anderson and they have shot a video in his style. There was a position for research assistant, and I straight away applied to that position.
So Wes Anderson was
one of the Wes Anderson was a catch for me. And of course, to many other things, the PM Lab is known for the aesthetics, the work they are doing in genomic sciences, the state-of-the-art technology they have, and many other things.
How would a doctor be interested in research?
It is true, and it is quite alarming that many of our doctors they don't take much interest in research. And when you see, when you look at medicine, it is always research driven and evidence based. अक्सर मंगवा यू करना चाहिए हम clinical practice को ना अगर तुम मतश practice ना वही. We call it evidence based practice. Where does that evidence come from? It comes from the research. From my childhood, I was interested in science in general. It was difficult for me when I wanted to decide where to go, towards medicine, towards engineering, towards physics, towards chemistry, because I was interested in all kinds of sciences in that time. It was difficult for me. I was interested in all aspects of sciences.
But what was this science?
This science, okay. It was of course, evolutionary biology.
Darwin's.
Yes, Darwin series and all that. And then evolutionary biology, and when you study species, the most, of course, all of the species that I study, they are interesting and that quite fascinating that you can really evolution go rich sanga jod shivi di the sanga processes rawan di you build sanga intelligence the behavioral patterns sanga di and all of them pediki we are to nazat of course the most intelligent species is human no aage baat human raa gaye no I thought chief of course evolutionary biology ji kam bilkul front bande ji kam species most intelligent the और ज़्यादा progress करे that is human species we're not study human species.
You've been like fond of science ever since you were a child, right? Have you ever had that moment where you were like, okay, wow, I could be a scientist?
It was back in 2003 when we would visit our elder uncle and during night we would do stargazing with our cousins and during that time we were kind of counting stars. And at that moment, I saw a star that was moving, and I asked my uncle, "What is that star?" And he said, "It is a satellite sent by the humans into space." And I was astonished that how can a human send something into the sky and becomes a star? Then I was trying to look for another moving star, and suddenly there's something appeared in the sky and looked like a fireball, and it was going through the horizon and it fell down in the nearest hill, and it gave a big kind of a light during night told Asarana Shuddha Shanti. And I was perplexed, my uncle was confused, everyone was confused what happened. And then I asked my uncle, what was that? And he said, I don't know. And he said,
I would think the world is ending. That's what I would.
Yeah. And
Wait, but what was it? Though?
So no one had idea. And then the next morning, another person, my relative, came from that area where that this happened. The fireball fell. So he said that last night there was something huge, like a fireball, and it fell near their house somewhere in the hill next to them. I started researching about it. And I came to know that there are small meteorites that sometimes along the course it can fall towards the earth. And that was the moment that I said, okay, so I have actually witnessed a meteorite. From that time I got interested in astrophysics, and then from astrophysics I kept on searching and reading in books about asteroids, about all the space discoveries. I'm also a space enthusiast as well. And physics, I do study physics these days in textbooks, and I read about it. I also read about medicine. So that is how you become more diverse, and that is how you are. I thought, okay, maybe I could be a scientist.
Coming to your lab work, right?
Yes.
So for those who don't know, what exactly is histopathology? But here, digital, in your case, it's digital histopathology,
so
right?
When you study the human body at the tissue level, it is called histology, study of tissues. Then histopathology, these are the problems with those tissues. The abnormal processes or abnormal the things or the problems that happen at a tissue level is called histopathology. So we are, how do we study these tissues with the help of a microscope? To study a tissue, you need to look at the cell. To visualize a cell, you need to make a slide out of it. So you get a biopsy or a piece of tissue from a patient. Through a process of slide making, you make a slide. You stain it with different dyes that contract some of the color. Tissue appear under a microscope is a pink or purple. The cells are the nucleus is it retains the color of it retains purple color, and the fluid that is inside the cell retains the pink color, the eosine. So you make a slide out of it, and then you place it under a microscope, and you study each and every, not each and every, but the cell as a whole, and you look at the integrity of the tissue. If it is disrupted, then it is pathological. If it is not disrupted, it is normal. But there are different features of normal and abnormal slide in histopathology. But with the advent of artificial intelligence these days and the advent of technology, so we had to incorporate this technology into health as well. because you can see that most of the things in the hospital are digitized. We use a computer-based software for it. We document every information of a patient on a computer. You see MRIs, CT scans, X-rays. These all films are now digitized. Same as the case with histopathology, it should be and it has to be digitalized. It should be digitized. It should be Mac compatible and optimized for technology. We thought, and even in the worldwide, people are trying to digitize histopathology by digitizing the histopathological slides. Like we have this microscope. It has a digital camera on board, which is 5 megapixel. You can digitize those slides with the help of this digital camera, and then use those images for different purposes. Using artificial intelligence, for example, you can predict cancer and non-cancer, as in this project. The most interesting part of this project is, so you have two options. Either you digitize slide as a whole, like you have big and costly and expensive scanners for it. You digitize each and every point of the slide of the tissue with high resolution and with image file which are with big large size. But you can also use conventional microscope like this and take small pages of the slide with low resolution camera, and that is the beauty of this project. We use conventional microscope and low resolution camera, like 5 megapixel camera. Why do we do that? Because we want that the model that we are going to train, artificial intelligence model, it should be able to make predictions using low resolution images rather than using high resolution images. Of course, in high resolution images, it is easier for the model to predict cancer and non-cancer, for example, in this case. But
you want it to be more feasible.
Yes, and low resolution, because there won't be high resolution image, whole slide image scanners, and somewhere in the periphery, in the mountains or in the hills, जहाँ पर कम के चलता histopathologist maybe, for example, in the periphery, your doctor there, he has a microscope, but he can make a slide out of it for biopsy on the field or somewhere in the Africa, or maybe anywhere outside there, where you only have a microscope. You made a slide, but you do not have histopathology pathologists around you. You can easily take a picture of the slide using the microscope with low resolution camera on your mobile phone, without using whole slide image scanner. As we have trained our AI model with low resolution images, that software will be able to tell the doctor whether it is cancer or not cancer. So for now, we are only targeting oral cancer, breast cancer, gastrointestinal cancer, and colorectal cancer. Using these, we can later on expand this project, and we can include other cancers, and then we can also include other diseases, not just cancers. And along with this cancer and these other diseases, we are including the normal tissues as well, so that the model knows that this is normal and this is cancer. So we are almost on the verge of completion of this project, and so far we are receiving really great results, of course. And we even tried that what if we could just take a picture of this, for example, this is a histopathological slide. We have even tried to take picture of this slide using our mobile phone camera, not using a microscope. And sometimes the model it gives us false positives and false negatives, but most of the time the prediction is right. Our AI model is so robust that it can identify cancer and non-cancer sections of a slide, even by using a low resolution camera on a phone. Normal tissue always follows a regular pattern, different compartments. When you digitize a small slide, a whole slide image, you might think it is such a small slide and it will just take a couple of pictures But no, as you see, as I said earlier, that a human body itself is a universe.
Universe.
In this case, I believe that a single slide couldn't be a universe, of course, but it could be a whole planet. So there's a whole lot of data on this slide, and for example, when you digitize a single slide with the whole slide image scanner, the files that it give you, it measures around 800 MBs to 1.5 GBs. Just a single whole slide image scan of a slide. That is how much data is in one slide. And when you read that data, the data on a slide, there's a term been coined for it, and that is called pathomics. Studying the data on a slide. So basically, we are dealing with pathomics and using it for the AI model training.
Oh,
Yes.
that's really interesting, Kamran. It's like, are you like collaborating with like tech experts in this?
Yes, of course. I'm doing the clinical part of it. I'm
Mhm.
identifying areas of cancers and normal tissues,
Mhm.
because on a slide you just don't get cancer cells alone. You get different kinds of tissues. You get reticular tissues. You get muscles. You get all the covering of intestines and stomach. But you need to target those areas only where the cancer actually is, and that is my part. I'm doing the clinical work here. I'm identifying those cancers, those areas on the slide, taking pictures of those areas that I believe that are important for the AI model to be trained effectively. So I'm doing that, and later on when I take all of these pictures, I'm not going to run any coding on it. I'm not going to run any AI models on it. It is the work of the tech
Data.
people.
Ah.
We have we have quite a nice team of data scientists with us.
Mhm.
One is doing bachelor's in artificial intelligence, and the one is done is bachelor's in computer science, and they are working on it. They are getting quite interesting results using the data set that we have produced and the AI model that they have trained.
So Kamran, let's go off topic. Can you give me like a typical day in the life of Kamran? Because I heard like, how do you balance your life? Because I heard that you're also like doing clinical stuff other than this,
Yes.
right?
Yes, I do my
And that
clinical
you
job as
do
well.
like 75 work hour shift.
Yes, there were times that I have done such long shifts, but it comes to your interest in your energy and your passion for your work.
Mhm.
When you like what you do, is the driving force for you to work long hours and balance everything. But of course, I do get ample time for rest, and then I woke up afresh with a big set of ideas to try and to search and to do research about and go on with life. So a typical day starts from, of course, coming to the lab, seeing all the beauty of Peshawar on the way, seeing the historical sites. I'm a history enthusiast as well.
You are big on history. I know from the tour how much effort you put into that.
So you see,
Yeah. You're a Victorian era freak.
of course, Victorian era or British Raj or any, I could become a freak of any age, of any era. You see, is it possible to walk all the old city in the heat of July, in the heat of Peshawar in July? But it always comes to your to how much interested you are in what you do. Same as the case with balancing out my clinical job and the research as well. So when I come to the lab, I straight away start up with my pending works. Right now, we are on the verge of completing this project, so there are only write-ups, and we do get time to go down and to the cafe and have some chit chats and exchange some really creative ideas. You see, there is that is the beauty of precision medicine lab, that when you have all kinds of people around you, you have engineers, you have artists, you have doctors, you have biomedical people, you have microbiologists around you. So you get new ideas and get the chance to discuss those ideas with you. And then after being done with my work here, I go to the hospital, look after the patients. And there is another aspect of my life that I find really intriguing, and I really like that.
It's like
when
you're a different person in all these, phases of your day.
Yes, that is true. So it always comes down to serving your people, because I believe that the best you can do with your life is to help others with your work, with your whatever you do, with your abilities and your whatever you have learned. So that is the prime. That should be the prime objective of your event, is to help others with your research, with your clinical practice, with your writing in your case.
Let's not get into that. Do you like the lab, Kamran?
Yes, I love the lab.
What is it that you like about it?
And so, as I said, the first time that I was impressed by anything in my local radius was precision medicine lab, with just one video that I saw on the internet, and of course,
Yes, the Wes Anderson
video. And then later on, of course, when I got to know about the research projects there.
Did you, by chance, ask anyone who made the Wes Anderson video?
Yeah. When I came to this lab and joined this lab, it was the first question that I asked from my colleague, and of course Dr. Mombal, who luckily she was my lab buddy. And I asked this question, who made that video? And she said, I made that video. So that was interesting for me to be with the person who made that video of the Wes Anderson. So about the lab culture, lab culture is quite creative. It is flexible. It gives you full freedom to entertain your thoughts, to entertain your creative ideas, just to come up with something so intriguing and nice in any field, not just medicine, not just genomics, anything related to science that you can offer to the society, to the people of the country or the world, if it has an impact on a global level. So we are on the lookout for such ideas on daily basis, and we do brainstorming every now and then. And that is the beauty of precision medicine lab, that as I say, that you have all kinds of
to be honest, my favorite sessions are the brainstorming ones. It's there's a million possibilities, right?
Yes, the possibilities are numerous, and but it always comes down to the feasibility of the project. So we sometimes you do get limited by the limitations that we have, because nothing is perfect, and there is always improvement. There is a room for improvement. Actually, I believe perfection is the long and ending and infinite road of improvement. There is perfection is, and this lab is an active example of that. It gets improved and perfected every day, and it in the same manner it perfects you. It improves you every day. That is what I like about the lab.
So you from what you've said, I feel like your favorite part is kind of the people.
Yes, of course, the people.
The environment.
The people that I'm around. Of course, the environment that they have created is the best part of the lab. Yes.
I guess we're progressing towards the end of the video.
Okay.
Kamran, is there anything that you would like to share? Any sort of advice you'd like to give to doctors who want to, opt in research, or who might want to after this?
Yes. So to the doctors, I would say that don't get just limited by your field or specialty. Keep on improving your practice. Keep doing research, not just about just you should. Every doctor should learn how to conduct a research, how to be curious and have the intuition. So what this lab has given me is the ability, is the quality of is the power of intuition. So I'm more intuitive now I was before. That I was before. I'm more intuitive now than I was before, and with intuition comes new ideas, and you stay curious all your life, and that is how your brain never dies and it never goes out of juice.
Yeah.
So
So there are like days in the lab where it's like when I have ideas and then I can't sleep, and then like those ideas are like constantly in
that
my
keeps
mind.
you
I'm
up
like,
at the night.
yeah, until they're like properly executed.
Yes, they are probably executed. And you look for answers.
Yeah.
And there is another message that I want to share related to this notion.
Okay.
That is, whenever you are curious about anything, it will always be answered. This way or that. Whenever you ask anything from nature, it gives the answer.
I remember the first time I met you, we had this conversation.
There's a term used for it, and that is it is actually a phenomena known worldwide. It is called the Betterman phenomena. That when you become curious about any topic or any concept, you get answers for that curiosity and for that questions that you have. And then another, I would also want to add that the most original and real concept that I've come across is the concept of being kind, and the concept of being a service to other people, which in another terms is called the concept of love. That how much you can give to your people, and to not just people, to all the living things around you, to cherish the life that we have. The pale blue dot, the earth, the only home that we have right now. We should cherish it and we should protect it from every harm. And by protecting, and how do we protect it, and how do we improve it? It is with research and innovation.
That was truly inspiring. Chalo, thank you so much for taking the time out for this, Kamran. I really appreciate. I know how busy, chronically busy you are these days. This is really nice of you.
Thank you so much for having me. Thank you for this opportunity to interact with the scientific community. It was really nice.